Let's get started with some two-sum. So the way this is going to work is I'm going to read you the problem, I'm going to solve the problem, and we're going to look at some tips and tricks throughout solving the problem that will make this problem and similar problems easier to solve. Alright, let's get into it. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input will have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Alright, so in the example they give us, our input array nums has 2, 7, 11, and 15, and our target is 9. And the answer is the array containing 0 and 1, because nums of 0 plus nums of 1 is 9. So you have 2, and we have a 9, and we're like, okay, which one? 2 plus what equals 9? We have 7, so that's why we have our 0th index and our first index returned. Same thing here. Target is 6, so 3 plus nothing will equal 6 here, but 2 plus 4 will equal 6, and we're good. Here we have 3 and 3 and 6, and we just return 0 and 1 because those are the indices of our targeted values. Okay. So I'm going to go through this in two different ways. The first way is going to be a bit of a brute force solution, and the second way is going to seem more complicated, but use a data structure, but lead to a similar result. So let's get started with our brute force solution. Now, before I code this out, let's look at how this would go. So if we have something like this, alright, so that's just a commented out block. If I have something like this, oh, did I do that right? No, I did not do that right. Whoops. Okay, this should work. Oh my goodness. There we go. Yes. Okay. Commented out block works. So if you have something like, as our targeted array, something like 1, 2, 3, 4, 5, let's say our target is 9. So how would we go about this in a brute force solution? So what I'm thinking is we'd have something like 2 for loops. So what would happen is we'd start at this first number in the array, 1. We're going to check, okay, does 1 plus 2 equal 9? No. Does 1 plus 3 equal 9? No. Does 1 plus 4 equal 9? No. Does 1 plus 5 equal 9? No. So we're going to check all the elements, see if any of their sums, any of their plus 1, if that sum is equal to 9. And our conclusion is no, it's not. Let's go to 2. So we're going to check if 2 plus 3 equals 9, no. If 2 plus 4 equals 9, no. 2 plus 5 equals 9, no. Okay, so then we're going to do the same thing with 3. 3 plus 4, 9, no. 3 plus 5, 9, no. What about 4? 4 plus 5, 9, yes. So this is the value we want to give. So hopefully that illustrated the type of brute force we're going to want to use. We're just going to want to loop through the array and look at all the indexes and see if eventually we get the proper sum. So let's code this up. If we look at our output, we're going to need a 2-index array. The first, or like the 0th index, would be one of the indexes, and then the first index would be the second index. So let's just create an answers array right here. I'm going to say int answer new int 2. So this array will hold 2 values, integer types. And okay, so now let's implement this brute force solution. So we're going to have something like for int I equals 0, I is less than nums.length, where nums is the input array, I plus plus. And now we're going to want a sub for loop inside. So we're going to start at this value, this 1 for example. We're going to want to start at the value to the right and then check the sums of these values. So if we start here, we're going to want to check 1 and 2, and then 1 and 3, and so on and so forth. So for int j equals 0, j is less than nums dot length, j plus plus. Okay, and then we're going to want to check if nums at I plus nums at j equals target. We're going to want to say our answer array. We're going to want to say answer at 0 is equal to I, and answer of 1 is equal to j. The order of these two doesn't matter. I could have said answer at 0 equals j and answer of 1 equals I. It doesn't really matter as long as we get both of them in there. And after this, we're going to want to return answer. And because this question says we'll have exactly one solution, we can go ahead and satisfy LeetCode here and have a return answer. So since we know that this function will have a return value, that there will be a valid pair, normally this would be okay, but LeetCode always wants a return outside at the very end of the function. So we're just going to provide it, even though this is miscellaneous. We're not going to actually need it. Okay. This is a brute force solution, and I actually purposely made one mistake in this solution just to point out something you might stumble upon when you're doing similar problems. So pause the video right here, and in 3 seconds I'll just go over it real quick. 3, 2, 1. Yeah, so the inefficiency in this program is coming from right here. I say int j equals 0. So if we think about what we're doing, what this really should be is I plus 1, and let's see why. So let's go through this example first. So at I equals 0, we start at 1, okay? 1. And if we add in j, if we start at the for loop j equals 0, we get 1 again. That in itself is an error because we're looking for pairs of numbers, not just a number being, half the value of the target, and you add it to itself. That's no good. We want two distinct numbers. So yeah, that's one reason that's wrong. And secondly, say it's inefficient. So say we say I is right here. So I is equal to 2, and it's at the number 3 right here. If I have j equals 0, I check, 3 plus 1, and then I check 3 plus 2, and then I check 3 plus 3, which is not even good. We don't want that. But what I'm trying to emphasize here is just 3 plus 1 and 3 plus 2. These are unnecessary calculations. Why are these unnecessary calculations? Let's go back to I equals 0. So it's at this value of 1. We do 1 plus 2, and then we do 1 plus 3. 1 plus 3 right there. It's the same thing here. So this calculation, if you start at 0, you're going to calculate this twice because you've already added this index and this index together. Similarly, if I equals 1 and we're starting at this value 2, we're going to have something like 2 plus 1, 2 plus 2. We don't even want 2 plus 2. 2 plus 3. This value are the same. So hopefully that convinced you that this should be I plus 1 and not 0. Real quick, if it's not clear why it's I plus 1 and not I, if I is right here in the second index pointing at 3 and j starts at I, then you do 3 plus 3. You don't want to do that. They're the same index. So that's why you want to start to the index directly to the right of it. Okay, so hopefully this works. Let's try it out. We're going to run our code. Alright, let's submit it. Yay, 100%. Not bad. Okay, now this code is optimized, but it's a little brute forcey. There's a cooler way to do it, not necessarily better, but a cooler way to do it, and I will do that right here as well. So now the way I'm going to approach this problem again is by using a hash map. So if you don't really know where I'm going with this, right away, feel free to pause the video and try and work through how a hash map could be useful. When I'm stuck on LeetCode problems, what I would do is I'll Google the solution, and I don't get anything from just looking at the solution, right? To get actually, have a problem spelled for you, you have to look at the solution, really understand it. I just try and find, the underlying idea behind it. So if the solution uses a hash map, I'd figure that out, and then try and solve the problem on my own using hash map. If it uses something like backtracking and I don't know what that is, I'll Google backtracking, and then I'll do the same process, try and apply it to the problem before I look at the solution. So, okay, now let's go into the problem. Basically what I'm going to do here is, let's see if I can do these comments right. Okay, basically what I'm going to do here is I want to create a map, and the key value is going to be the value at an index, and this is a little confusing, and the value will be the index. Okay, so what do I mean by this? So say our array is this. Array is 1, 2, 3, 4, 5. What I want to do is I want to create a map so that the key value, so let's say we look at this, for example, this first index. Key value, I want to be 1, which is the value, and I want the value of that array index, and I want the value in terms of the map to be 0. So it's a little backwards, it's not usually how we think about it, but I want the value as the key, and I want the value in the array as the key, and I want the map value to be the index. So, okay. Hopefully that was clear. Yeah. So let's first create a hash map. Hash map, and it's going to be integer map equals new hash map integer. Ooh. Okay, so just to clarify what's integer, this first one will be the value at an array, so like 7, and then the second one will be the index of the array, so for the 7 it would be 1. Okay. Oof, that was a doozy. Now this is what we're gonna do. We're gonna go through the targeted array they give us, and then what we're gonna do is we're gonna check if target minus the current value is a key in the map, and if it is, we're just going to return the index we're at plus the value from the map in the target minus current key. We'll be done. So as in last time, that was a little confusing, but we'll see as I code it out. Int answer equals new int 2. Okay, 4 I equals 0, I is less nums I plus plus. Alright, so now we're going to have to do the map thing. If we're going to want to say if map.contains key target minus nums I, we're going to want to say answer 0 is equal to I. We're going to want to say answer of 1 is equal to, alright, think for a minute what this would be. The map.get target. Why would it be map.get? Ooh, not target. Whoops, target minus nums of I. Yeah, funny joke, Neil. Okay, why would it be? Why is this the case? So the way our map is set up is the key values of the map are the values in the array. So like 1, 2, 3, 4, 5, or in this case 2, 7, 11, 15, right here. So if the map already contains, so target is 9, say that, and we are at let's see, say we're at 7. So we get to 7 is not in the map. We move on from 2. we go to 7. 9 minus 7 equals 2. 2 is a key value in the map. So then, okay, we have 7, we have 2. And then the values for that map are the indexes. So now we can just set the indexes to our answer array and return answer. And as I said before, LeetCode demands return value. So we're just going to return this even though it'll never actually get here because we're guaranteed there'll be a solution. So yeah, that's about it for this. Let's make sure this works first. No. Okay. Here's the numbers not length. I don't want to go down 10. Wrong answer. Why is this the wrong answer? Let's see. For int I equals 0, I is less than nums.length I plus plus. If map.contains target minus nums of I, answer of 0 is this. Okay, equals I. Map.get target minus I. Return answer. 0 and 0. So if map.contains target is 9. So 9 minus nums of I is 0. So we want to say answer of 0 is equal to 0. Okay. Why does this work? Why is that? If map.contains key target minus, so if it contains key of 2, we want map.get target and then we want I. This should work. Let's go to our submissions, previous answers, and see what's wrong. Where's my solution with my hash map? Here we go, finally. Oops. Okay, let's see what's wrong. Okay, int answer. Map.contains are good. Oh, I never put anything in here. Oopsie. Map.put nums I, comma I, and that should work now. I never actually add things to the map. Interesting. We submit. Yay. Okay. That was cool. Alright. That's it for this video. I know I'm going to re-record it, but it was cool to do it anyways. See you next time.